And we are now recording. All right, so with that, we will kick it over to John Redmond. Thank you so much for presenting today. The floor is yours.
Yeah, I just want to really thank everyone for the opportunity to present this information today. So uh, I think it's kind of niche a little bit. Not a lot of people know about it. So I'm hoping it's going to be informative. And please, if there's any questions, ask them during the presentation so we can keep clarifying them as we go. But this is for UN 38.3. So next slide, please. So next one, the UN 38.3 is really, it's a certification that is built upon by the transportation agencies globally. So the UN, it comes from the United Nations where the global regulations start for lithium batteries. And it's meant to be there for everyone to protect and ensure safety. So it's a robust series of tests, and we'll walk through what each of those are. But it's performance based. It's globally, and it's any battery that's being placed into transportation must be certified under this certification in order to be transported. All right, and that includes inside of a vehicle. So if it's over a public roadway, if it's in the air or ocean, it's going to be fully regulated, and this test would be required. All right. So next. Okay, so why is this important? Now, I could have provided a slide that shows building fires, fires on aircraft as well. There's several different building fires that have cost tens of millions of dollars of damage. There's aircraft um, that have been impacted by lithium batteries fires that are in the hundreds of millions. But the vessel fires are something different, something unique to Hawaii. So I wanted to cover those. But for a time there, we were losing a vessel about every 8 months at sea. So if you look at the Felicity Ace in 2022, that was a vessel ship called a ro-ro ship, and it means roll on, roll off. So they are huge floating parking lots. So some of them can hold up to 7,000 to 8,000 vehicles are parked on those vehicles, and you drive them right up and park them in a spot, and they secure them. So on the Felicity Ace, it was had about 5,000 vehicles from all different manufacturers. One of the manufacturers, I won't get into which OEM, but they were transporting one of their EVs. It wasn't properly managed, and it ended up having a thermal event. Not only did, and it was right off Portugal, so going through the Azores where it hit some rough seas, ended up having a full thermal fire, and the vehicle the ship had to try to be recovered. It ended up being lost at sea. So total loss of cargo is about 401 million. Total loss of the vessel is at least 50 million. And then there's other insurance claims and stuff on top of it. So when it's all said and done, this single OEM for misshipping a single vehicle is looking at somewhere between 500 and 750 million dollars in fines and penalties. Now you think of the vessel operator loses that vessel for years. So to get a new ro-ro ship built, you're looking at least 3 years in order to do that. So that significantly impacts their costs as well, which is why we see the scrutiny of not wanting to take lithium batteries and EVs onto the vessels. The Grande Costa is one in 2023. It was in the port of New Jersey. This wasn't started by a lithium battery fire, but because where the fire started, it was in close proximity to some EVs, caught fire. And the tragic thing there is a couple emergency responders lost their life fighting that blaze. And then we had the Fremantle Highway, which is another one up in the North Seas uh, off the coast of Europe. This one was able to be salvaged. They brought the ship back into port and was able to be repaired. But you're still looking at well over when it's all said and done, probably 400, $500 million in loss. And then the most recent one is really the Morning Midas incident, where fire coming from China, bringing EVs into South America, caught fire, total loss of the ship off the coast of Alaska. This one, when it's all said and done, is from what we're hearing, is going to be similar to the Felicity Ace. So the OEM would be out probably looking at somewhere around $700 million in fines and penalties, as well as that vessel operator loses their ship and the ability to move things on a ro-ro vessel for years, at least 3. Next slide, please. Okay, so just a real quick overview of the regulations, where they come from. So you have the UN model regulations. They write what the requirements are, including the UN 38.3. It's then adopted by IMDG or vessel, ICAO for air, and IATA for air as well. And then it makes it into the different nation states, like the US DOT, PHMSA, EU ADR, China MOT. And then it works its way into different standards like the IEC and also the SAE. It's just kind of the flow of the regulations. Okay, so what are the regulations for a battery? We can go to that next slide. So lithium battery identification or classification is it's going to be a UN 3480, the battery by itself. It has to be classified under the UN manual testing criteria, section 38.3. And it covers all battery types have to go through this testing and certification. So every battery that you will have on your market most likely has to be certified, or it would be a counterfeit battery, which means it hasn't been tested through performance testing to determine that it's safe for transport. And we know how much energy is in these batteries. And so we know how robust this testing has to be for the global governments to sign on to this requirement to really protect people and vessels in transport. Next slide. Okay, so we have the manual, the transportation dangerous goods manual testing criteria. It's going to cover section UN 38.3. It's transporter regulations require all lithium batteries to be tested, and the class, the UN 38.3 classifies the battery design type. So if you change a design type or modify a design type, adding additional cells, adding different hardware, it would change the classification. That certification would no longer be appropriate. But the tests in UN 38.3 start off with an altitude test, so a T1 test. So you have to simulate the pressure, high pressure, and low pressure to prove that your battery, when it's exposed to these different altitude differentials, that it doesn't have any kind of failing criteria. It doesn't swell, it doesn't leak, it doesn't create off-gassing, it doesn't spark, and it still is good to be charged after. So there's certain pass and fail criteria. And then you have a thermal shock, a T2. So you run it through temperature differentials, both hot and cold. And the battery has to, once again, pass those tests and not meet any of the failing criteria. There's a vibration table to simulate some of the vibrations that the battery may be exposed to in transport. There's mechanical shock, which is really kind of like a G-force test, that if it was involved in an accident or a certain impact, that it would pass those tests as well. And then there's an external short circuit test. So those are just your first 5 tests. And then there's additional T6, T7, T8 for impact of cells, where they have to go through a certain impact and be able to demonstrate that they won't rupture, they won't have a thermal event. Overcharged for the battery only, and then a forced discharge, because really when you overcharge a battery or you force discharge a battery, it's when they can become unstable. So you have to prove that your design type will pass all those different criteria. All right, so next slide. So some definitions. So what is a cell? A cell means a single encased electromechanical unit on one positive and negative electrode, which exhibits the voltage across the differential of the terminals. And then the battery is 2 or more cells which are electrically connected, fitted to devices necessary for use, for example, case terminals, making protective devices. So if I have a cell, is one single unit, anode, cathode. I connect two of those cells together, it becomes a battery. If I connect multiple batteries together, it just becomes a larger battery. Every time I would make one of those changes, based on the design type, I have to go back and recertify that battery under UN 38.3, or it's illegal to transport because I haven't proven it's safe for transport. So battery packs and modules, I have a little visual below that kind of shows, the movement or the transition from a cell into a module or a battery into a larger module and then into a pack where they would all be contained. But that's kind of the different options that are there, and all of them would fall under UN 38.3. It's important to note that if I change any of those, if I change my cell, if I change my hardware, if I change my terminals, if I change my bus bars, if I change the wiring or any of the protective fuses, any of those changes are going to be considered a new design type that would push me back through to retesting. All right, next one. So large battery versus small, there's some differentials there. Especially doing with the shock test and some of the vibration tests, they realized that the tests originally, when we first developed this, was for small batteries. No one had an idea that a battery would, approach, 2,000 pounds or 2,400 pounds. So as we've kind of made those differences, that there's been some exceptions that have rolled out for, some of your larger batteries. And they're just indicated there. But so you have a small battery, you have a large battery, and then you have large battery components that would all fall under UN 38.3, all have to be tested, all required by law. Next. Okay, so recertification. So when does a recertification occur? So remember that certification is by design type. So if I design a AA lithium battery, every one I produce under that design type is going to be covered. If I change my anode or my cathode material, if I change the inner workings of that cell, it's going to push me into a new design type that I'd have to recertify. Same with the battery. So if I have a battery and I change anything to it, once again, it's going to push me into, it's a different design, and I would have to go through and make those modifications. So manufacturing location, it doesn't depend on the manufacturing location. It's really going to depend on, do I have the same quality management system? Do I have the same components? Do I have the same material that are all designed? And if not, the batteries, would have to be recertified. And it's one thing that it really calls out, that it shall be manufactured under the exact same quality management system. So even if I was taking batteries or cells from batteries that are available in the market, and I'm taking them apart and I'm using original OEM parts to recombine those, if I don't know what their manufacturing quality management system is to repeat or have that repeatable process of developing a product that would pass that design type under their management criteria, it's a different design type. And you would have to develop what that quality management system requirements are and then recertify that under your own company's name. So repair, reuse, reman, same thing. So when a replacement with non-original spares, parts of a different specification or under a different quality management system, those would be considered counterfeit batteries. You would have to go through and recertify those under UN 38.3. Okay. Next. So kind of the hazards of the classification tests. So they are looking at right now. We're in the first cycle of the biennium at the United Nations. They're looking to add in. We have the T1 through 8. They're looking to add in T9 through 13. And these tests are really about the hazards that each battery has. So you could be shipping a battery, let's say it's a 300 watt hour battery for an e-bike. You could ship that, and that's a UN 3480. Or you could be shipping a battery that's 2,000 kilograms that is 210,000 watt hours. instead of 300 watt hours, 210,000 watt hours, and both of them classified for transportation would be a UN 3480. The carriers and the government agencies wouldn't have clarity by what you're declaring to know what is the difference of the hazard between one UN 3480 and another UN 3480 or one lithium battery compared to another. So they want to develop a hazard-based classification where you would be able to demonstrate the hazards that your specific battery posed during transportation. And that's where you get into your T1 through 8 is really the cellular battery. The T9 through 13 is really going to be the battery and how it performs. Does it propagate if there's a thermal event initiated? So does the fire, the thermal reaction of the cell, does it go from cell to cell and from battery to battery inside of a pack? Does it produce gases? Does it produce flammable gases? And what is that overall volume of the gases that it's producing? So the new tests are really say that, hey, if I have a battery that's been engineered and designed where it won't have a thermal event, compared to one that does have a thermal event, that they should be able to be transported differently. But you have to prove that your battery is safe. Right, so next slide, please. To do that, it's kind of this scheme is what we're kind of playing with right now at the United Nations. So this is kind of what's proposed, that you would take a cell or battery and you would have it at 100% state of charge, and then you would run it through a test with the thermocouple on the side of the battery to push it into a full thermal propagation event, a full thermal event. And then you would measure it down to the tree. That does it propagate? So do you have a full thermal reaction, or is it only within one cell? Does it produce flames and heat? Does it produce these gases that are both explosive and toxic? And how many gases it has? And then based on it, how your battery would perform, it would put you down into one of the boxes below. And if you can show that your battery is benign, where it's not going to react in a way, it's going to be able to be moved with limited packaging or shipping criteria. However, if it falls on anything on the right side of that chart, it's going to be fully regulated, and you're going to have some sort of way to mitigate the thermal reaction or the hazards that battery would pose. Maybe through packaging, maybe through modal carrier requirements, restrictions, something along that line. But the batteries would be tested at 100% state of charge. So you would recreate a worst case scenario, and then based off that scenario, your battery would be evaluated. Now, there is a lot of talk right now that perhaps you can use state of charge as a mitigating factor. So you would have your battery tested initially at 100% state of charge and how it would react. And then maybe you add in a 30% state, you retest it at a 30% state of charge, and you can move down the risk hazards from right to left. You can get into a lower risk hazard, which gives you greater flexibility to transport, but you would have to prove it. But that's one option out there that's being considered. Next slide. So the three questions that I had from the group. So is there a certification training program for auto repair businesses that repair EVs to perform UN 38.3? No, I've never heard of one. The battery manufacturer is responsible for conducting the UN 38.3 test. If you perform any kind of repair on that battery, modify that battery, it's a new design type that the new person who did something with that battery would be responsible for meeting that criteria. It's a pretty long process. It's about 7 months to get a battery tested, and it's quite costly. But I do not know of any training programs, as most of them are done through labs. Are you aware of any businesses in Hawaii that are able to meet the UN 38.3? No, not to my knowledge. There isn't a lab on any island that I know of that does UN 38.3 testing. There's a few of them in the U.S. Usually that's where US, China, but usually either the OEM has built a lab that has the capability to do the testing and certification, or you send it to a third-party lab to have it done. There's a couple really good ones out there like Intertech that would be able to perform the testing, but there's numerous labs out there that can do the UN38.3 testing for you and is certified under that standard. Now, if you go to a lab, they have to be certified in order to do that testing. And that's a process in and of itself. So is there any UN standards that the battery needs to meet to be refurbished into something other than cars? So all lithium batteries that have been modified from their original design type have to be retested UN38.3. There's FMVSS standards, codes, so your Federal Motor Vehicle Safety Standards. There's your ECE, which is an economic global standard for vehicles for the UN38.3 as well. But I think it's important to remember that the tests are for on the design type of the battery. So anytime that something would be changed, you would have to recertify. There's also a provision for prototype batteries. So if you have a prototype battery, which is one that you've developed either through a low production run or it's a prototype, so you're playing around with something and you're not sure how it's going to work in your vehicles or your market or anything else, and you can transport it as that prototype or low production run for testing purposes, not for selling, but for testing purposes. You're moving it to test that battery to see if it's going to meet any of your business requirements to then turn it into a mass manufactured battery. But outside of those, it has to be UN38.3. The only other exemption is if you have a UN38.3 certified battery or a battery that you come in contact with and you need to move it for disposal or recycling purposes, you do not have to have a UN38.3 certification on that battery. One of the difficulties with that is if you're moving a battery and if you're moving it for recycling and disposal, but there is any damage or it is acting in any defective manner from the design type, then you have to defer back to your damage defective transportation requirements, which are more restrictive. It has to be marked on your packaging and you have to declare it to the vessel operator. Okay, so with the other standards, I just pulled some of the standards that I'm familiar with, and it's in the next few slides. It'll be pretty quick as we go through those. But if you could go to the next slide. So in vehicle safety standards, this is the list of the standards that I'm aware of. There may be others out there. This is not meant to be all-inclusive. Some of them are going to be required. Some of them are going to be voluntary standards as well. But these are the standards that I'm aware of for in-vehicle safety standards for a battery. Next slide. So this is design and performance standards. So ISO, IEC, and these cover not only batteries in vehicles, but also just regular batteries. Now, a lot of these are going to be more voluntary standards for people to abide by, but they are still standards and criteria as well. Now, any of these standards, if you use them on your battery to prove that they're safe, doesn't negate the UN38.3. The UN38.3 has to be required for any battery that's being moved. I don't know if there was a comment there. And then next, oh, my box is off. Industry best practices for OEM. There's some other standards, some of your SAE standards that are up there. Some OEM internal standards that are available. Your UNR 100 is a big one. Your nail penetration. Some companies, organizations really like to focus on the nail penetration without a flame. And then you have drop tests and the different coolant leak simulations that are available out there as well that some OEMs have. And then you have OEM innovations as well. So pyrotechnic disconnects, gas sensors, early detections for thermal events within vehicles or within different operating units. And, when we talk of EVs in the transportation realm, it's just always good to remember that covers e-bikes, that covers automobiles, that covers drones that you can fly in, anything that a person could sit on or sit in and operate that would be battery powered. So some of the key takeaways, most OEMs are going to exceed some of the compliance standards. The A lot of the standards are integrated into other regulatory requirements, or they have some alignment there as well. And proactive safety is what we're trying to push people through to through those requirements, like in the UN 38.3 and those new tests. We want to promote a safer engineering and design battery so that we can protect not only the people that are handling those batteries, but our loved ones and the public as those batteries are being transported through either air, ocean, or ground. So proactive safety equals fewer recalls, equals stronger EV and the safety record, and that's something that I think everyone would support. And I believe that's it. I believe that was my last slide. So any questions for me?
I had a quick question, just out of curiosity. Great presentation, by the way, John. One of your slides, it said, that the batteries shall be manufactured under a quality management system. Is that like ISO 9000 or?
Yeah. Yeah,
Okay.
so there's a couple different quality management systems out there you can use. Most people are going to be using like an ISO quality management system, but it's really to ensure, that repeatable quality is built into every product that's being produced, which is really important for batteries. So if you're producing a battery, you want to make sure that you're, prohibiting any kind of quality defects as it's leaving your facility. So that quality management system is a critical piece to battery manufacturing.
I have a question, if that's okay.
Yeah, Michael.
Hi, John. Sorry I didn't get a chance to meet you earlier by the invite from Eric, but glad to finally meet you. It's kind of a comment that you can comment to, but from the reports of my working groups, I do want to point out that UN 38.2, it is only for new batteries that have been, and it's a test on the manufacturing process of batteries. It's not a test applied to every single battery that's sold and shipped. It's a test applied to a small sample of batteries from a given manufacturing process. And there's an assumption that if a small fraction passes that test, then that manufacturing process is okay for any battery manufactured that way to be shipped. More importantly, though, for Hawaii in this working group, it is not a technique you can use to address waste streams of lithium-ion batteries, especially 7 to 8 years after they've been purchased and they've been used through all kinds of cycling, exposed to different temperatures, different kind of physical stresses, and so forth. It takes way too long to test it. It's way too expensive, and you can't test every single battery that you ship. And even if a battery passes a test, it still has all the ability for explosivity and flammability if it's adjacent to another battery that does ignite. So the other thing is that it's really unrealistic to even think of testing batteries, especially the small formats. And they are just as important to addressing waste streams in Hawaii, because if they start fires on ships, it's going to impact everybody else, even those that have followed the rules. John, is that close
Yeah,
to
yeah. So I would love to weigh in on that. So you're absolutely right. Not every battery that is manufactured goes through the UN 38.3. It is design type testing. So you create a design type, and then you use your quality management system that proves everything being manufactured meets those same capabilities. And it is by every manufacturer. So that if you're putting a battery on the market, even if someone's reselling it, it would still be covered under that UN 38.3 certification. Now, what it doesn't cover, and I think that's a really important point that you're bringing up, is if it's been abused and end of life, that 38.3 is for a new battery design type. It doesn't cover batteries that have been abused or anything else. And that's where it's really important, critically important, to not only have a strong understanding of batteries, but using criteria of how you define what a damaged or defective battery is, And then if it does meet that damage affected battery, so you're going to have to transport it in, special packaging or different, more restricted packaging. How do you identify that that battery is stable or unstable? So you may have a damaged battery that you need to put special care with. But if it's showing signs of instability, now you even have to go further. Now I should be either isolating it until it becomes stable or putting it in some sort of packaging that would help mitigate an issue if it did have one, because you know that there's something wrong with it. It's showing signs of heat or it's something else. So, but that's really critically important, that because it's a battery once and it's certified under UN 383, that doesn't mean that's what your classification and handling procedure should be through the whole life cycle of that battery. It changes depending on potential abuse, exposure to weather, salt water, things like that. But that's a great point, Mr. Cooney.
Hey, John, this is Eric from Calder Recycle. I had a question for you.
Yes, sir.
So thank you for going through the presentation. Um, and one kind of comment to add to piggyback on something, and then one actual question for you. So just for the clarification of the audience, several of these tests are physically destructive in nature. So the tests actually do say which ones you can use the same battery. You can use the same battery for test 1, 2, 3, and 7, or whatever it may be. Those aren't the actual numbers of the tests, but it's that format like that. And then certain of the individual tests, you have to use a new configuration battery or cell on, because that actual test is designed to create with the battery. But the question is, what do you think some of the ways that the UN 383 testing are most important, or most pertinent to the waste stream, considering that, as Dr. Cooney said, these are for new batteries? And then could you spend a little more time talking about um, the Second Life industry and how that fits in the 383 testing, whether it's by big enterprises and organizations? If an auto OEM is remanufacturing batteries under the same spec, would those batteries still be okay to ship versus maybe doing something fundamentally different with batteries, or maybe even a homeowner doing a DIY application?
Yeah. Hey, Eric, can you repeat that first question? I want to make sure I answer that one correctly. My
Well,
mind started racing on the second part of it. I apologize.
The first was really a comment, and that was just saying for the audience clarification that some of the tests are destructive in nature,
Yeah.
and so you're certainly not doing it on every single battery, because on some of the tests you're destroying. The actual question is asking you to spend a little more time talking about how the 383 tests may be most pertinent to end of life battery management in Hawaii, and maybe how the Second Life industry fits in, because Second Life can mean a lot of things. There are auto OEMs who remanufacture their own packs. That might be being done under the same quality system with the same feedstock, same material. So if a OEM is swapping out whole components of a battery, maybe it's still covered, versus somebody doing something totally different, maybe it's not covered.
Yeah, I think that's a really interesting question. So thank you for asking that. So your UN 383 is really how you're going to prove a battery is stable right now. So a battery that's been manufactured in that process or under that UN 383 criteria, the battery is going to be known to be stable. You don't know what level of abuse it has. So for end of life cycles, if you have a battery that you're able to, visually assess that there's no scorch marks, there's no rust, there's no water damage, there's no physical damage, you probably have a pretty good idea that that battery is stable because you're able to demonstrate that it was a UN 383. Now, I wouldn't bet the house on it. Yeah, I think you still should do, if you have heat guns and stuff like that, you should still be using those for some further analysis. But a UN 383, you're going to know that the battery was manufactured at a high level. If you can't track down a UN 383 test report, it's kind of like a safety data sheet for all lithium batteries. Every lithium battery would have one. If you can't really track that down, then I would use more caution with handling that battery. I think it's difficult. Now for the secondary life, so if you have a UN-38-3 battery, like I said, you know it's been manufactured under a quality system. You know that there's been a lot of investment in that battery design type. So I would have more confidence in how it would be used, whether I'm going to use it in another vehicle application, something like that. But it all depends on what abuse that battery has. So if that battery has suffered some abuse, it doesn't matter the UN-38-3 certification or not. It's not going to be safe to handle, to put in your home, anything like that. And then remanufacturing. So where the UN-38-3 comes in, I think on the like secondary use end of life, is if you're going to start using that battery into different applications, especially if you've modified it at all, I would definitely recommend putting it through some testing. If it's never any transportation and you're just going to install it in your home or something like that, using the other tests that are out there to demonstrate that it's safe. But UN-38-3 is really a design type for a new battery that hasn't been abused. Once it leaves that manufacturer and there's abuse, and especially at the end of life, it's not going to mean a whole lot, which is where that test summary report isn't required for transporting batteries that are being shipped for recycling or disposal.
John?
Yeah, yes, sir.
Another question. First, the context to the question that our working group went through a lot, and I talked to Eric at great length about. But to begin with, when you talked about DDR batteries at the end, you have to verify they're not DDR batteries after the life cycle. I do want to point out that we're not talking about looking at an entire EV battery and looking at it and saying, oh, it looks like it's intact and it's in good shape. We're talking about looking at every single individual cell packed within that battery. There could be up to 1,000, if not more. And if you're at a state level processing any given number of batteries at all scales on a daily basis, you're talking about having to inspect every single battery. And even then, if it doesn't look like it's damaged, you don't know internally whether the membrane is close to fracturing internally, because we don't have a tool to see inside. A heat gun might show you at that moment in time there's no heat evolution. Doesn't mean it's not going to happen in 2 or 3 days, or if there's some sort of shifting during the shipment. With all that said, the question is, there is a law in CFR, the code, that says it is illegal to ship any lithium-ion battery that has, without guaranteeing it cannot undergo a rapid evolution of heat. Now that's impossible because we don't really know whether internally the short circuit's going to occur. But I think the way they get around it, and I've talked to Eric about this, is that if you pack those batteries individually in individual wrapped bags, and then you put them in a fire-resistant retardant, and you pack them sufficiently distant from each other, the idea is that if one erupts, it won't ignite and spread the fire to the next battery. And that's how they get away with that law and the scrutiny after a fire, that did somebody pack a battery without being able to guarantee there wouldn't be a rapid evolution of heat. Is that your understanding of it, or am I really off base?
No, so what that section is, it's in 173, 124, I believe, or 173, 24, I believe, maybe 25. I was going to pull it up real quick and I could share it in a screenshot, perhaps. But if you have a lithium battery, it's in a forbidden of items that are forbidden to transport. So if you have a battery that's liable to have a thermal event, it's illegal to place into transportation unless it's packaged and secured in a manner to prevent that occurrence. Now, that's kind of a high threshold, but that's not for a UN-38-3 battery. That's talking about a battery that is somewhat liable to have a thermal event. And that's in I would say general industry, that would be considered as, something outside of a regular 38-3. So that would be something that has been abused, that has known abuse, and you have to do something with it. And what that would really trigger for us compared to Europe In the US, we would say we couldn't ship that. So then what we would do is we would fall back on three criteria. So one, your physical observations of the battery. So what can you tell from the outside of the battery? Something's potentially wrong with it. How do you determine if it has the propensity or is liable to have a thermal event? So look for the obvious signs of the physical damage. DOT has a really good brochure on DDR batteries where they walk through different criteria. And then I would say the second piece of that would then be looking at what are the other things you can monitor. And I think that's where the radiant guns and stuff are really helpful to detect that if it does have some sort of level of heat or there's something going on internal of the battery that you can't see externally. And then the third one would be if it's a battery that was in a vehicle, hopefully you can track down your DTC codes. So there's going to be codes that are going to indicate that the battery may have something wrong with it, that is showing some instability and that it needs to be replacement. If you have a record of those DTC codes, not only do you have an analytics pointing you to that there's something wrong internally to the battery, that may not be observable from the outside or the use of extra equipment such as the heat gun. So I would say those three things would be required. If it does meet those, then I think that's what triggers 173.24. And what I would say then is you should be putting it in packaging that will contain a thermal event and manage the gases that battery would be producing. And that would meet the same requirements for P911 within the European Union, had that they distinguish between a damaged affected battery and a damaged affected battery that is likely to have a thermal event. And if you have one that is likely or liable to have that thermal event, you have to go to a more restrictive packaging that will mitigate that the battery if it did have a thermal event, containing the thermal event and managing the gases it would produce. I hope that helps.
So,
Mr. Foolish, I see you have a question as well.
I just had an ad, and John, great presentation. With the UN tests, there are requirements on the component cells that they're obviously they're tested when they're new, but there is a component in there too where there's a certain amount of cycles they have to go through. It's 25 cycles, and they also have to go through the tests. So they're not necessarily end of life, but they're not new anymore at that particular point. And then on any types of batteries that are reused or repurposed or whatever, if they get built into something else, the UN model regulations do have a criteria in there for and a list of different things to look at, that if the batteries have any way of failing the tests, and again, there's a list of things that are in there, if they check any of those boxes, then theoretically that battery would have to be retested before it can be transported again.
Unless it's transported for disposal and recycling purposes.
It wouldn't be for disposal and recycling. It would be for if they're repurposed. So if you take like a EV battery, take it apart and make it into something else, if then generally speaking, that's no longer a tested type. So that would require some retesting.
Agreed.
okay, great. Love all the conversation that's been happening. If there's any further comments, we're gonna leave those till the very, very end of the presentation so that we can move forward with our next presenter, who is Kevin Moy from the State Energy Office. And
Got the floor.
Cool. Great. Thanks so much. And thanks again, Menashe, for the opportunity to present in this working group session. Again, my name is Kevin Moy. I'm the Energy Resilience Project Specialist here at the Hawaii State Energy Office. And today I'm going to be talking about some work I did in my PhD related to transportation batteries for second life stationary storage systems. Next slide, please. Right. Yeah, so just a quick summary, just to, before I kick off. But basically, the crux of this is just after being used in high power transportation systems, like, electric vehicles, also any other kind of transportation systems that may be present in the future, like, electric airplanes. These lithium-ion batteries could potentially be repurposed in second life high energy applications, such as stationary grid storage. But on the other hand, battery degradation and aging is complex. It involves many different processes and affects the health of these overall retired EV lithium-ion batteries. Um, Finally, predicting the state of health of these retired EV lithium-ion batteries is an active area of research and impacts the value of second life batteries. Next slide, please. Right. So we talk about first and second life. I just wanted to kind of outline this. This is a diagram I've used pretty often in my work. But essentially, we're kind of looking at the battery capacity as a function of its lifespan. So you can see in the first life, and typically in EV lithium batteries, we're taking them straight from manufacturers, putting them right in the electric vehicles at 100% of its stated capacity. You drive it around, you kind of using it along its first life in an EV. And then typically when it gets to around 80 to 90% of its original capacity, we can then say it's retired from its first life. And then it can then be repurposed in second life applications, including on the grid as a stationary storage. Then in its second life, you can see it kind of hits this sort of what we call the knee and capacity, where it tends to drop off from relatively rapidly in capacity. We would consider that kind of maybe unsafe or unstable for second life usage, and that would be more appropriate for recycling. So the three stages would be first life, second life, and recycling, moving left to right. Next slide, please. Right. So why are we even talking about this in the first place? That's sort of this sort of parallel this growth of electric vehicles in the world, as well as the growth for demand in the grid storage. So on the left is a diagram from Bloomberg NEF done a couple of years ago that sort of is looking at the fleet turnover to electric vehicles potentially being the main global vehicle type by 2040. Again, assuming no new policies or rules enacted, and obviously in this current climate that's subject to change as well. But at the same time, in parallel, if you look at the plot on the right, there is a growing demand for grid storage, reaching about 180 gigawatt hours in 2030. And so what this plot on the right is sort of showing in these gray and blue bars is showing how potentially the supply of retired EV lithium-ion batteries could potentially meet this grid storage demand by simply reusing them or repurposing them for grid storage usage. Next slide, please. Right. So when we talk about energy storage and electric grid, there are many different places they can be used. So this plot on the right is one that's commonly used to just show where grid energy storage systems, or ESS, you can see in these red boxes, can appear on the grid in many different spaces. So, at many different scales. So from the megawatt scale or gigawatt scale all the way down to watts is a little small, but usually down to kilowatts. So you can imagine having them co-located energy generating facilities. You can imagine them being co-located with solar or wind for supplementing those intermittent resources. You can also think about distributed energy resources. So those are, more of the consumer type at the grid edge, supporting individual households. And the discharge duration also changes a lot. So you can think about, inter-day peak shifting. So that's, relatively long scales versus something like voltage support or frequency regulation that typically happens, on the minute scale, and that requires very fast response times as well. On the right is showing basically many different kinds of energy storage technologies. Lithium-ion batteries are in this bright red box, but this is mainly just to show that there are many different kinds of applications of energy storage on the grid. You can see from left to right, customer, industry, distribution support, transmission support, even bulk storage. And on the vertical y-axis, you can see, it can range from seconds to multiple hours or intra-days, and from scales from kilowatt to gigawatt as well. So all this is to show that, there are many different places that energy storage can plug in to the electric grid. And lithium batteries could be one source of that capacity to support these applications. Next slide, please. All right, so that all sounds good. But the problem is that battery degradation is very complex. And so we mean degradation, we're talking about losing usable capacity. So in other words, using the amount of energy that you can use, that you can extract from the battery for useful work. The other thing that often typically happens is an increase in resistance. So this is, reducing the amount of power that you were able to extract from battery as well. And this diagram is one, again, that we use pretty often. I'm not going to walk through every single process, but this is just to show that there are many different components in a battery. There are all of these electrochemical components that have, very complex electrochemical processes that all interact in very different ways, that result in degradation, that results in lots of different, degradation and aging patterns. And so these manifest in the larger scale in terms of loss of energy and power, but there are lots of different processes that affect that. And so it's very hard to predict how those evolve and predict how that affects the eventual kind of output or state of the battery as well. Next slide, please. Right. So I hinted at that in the last slide, but essentially battery degradation depends very highly on usage and conditions and usage. So there are three kind of main things that I think about in terms of things that affect battery health throughout its lifetime. The first is very important. So how the battery is cycled. This was a major focus of my research, is looking at usage patterns and applications and how those differ and how those affect how the battery ages as well. The second is pretty straightforward. So operating temperatures, you can think of, extreme heat and extreme cold are typically not very good for battery health. They typically lead to faster degradation rates as well. And the last is the depth of discharge. This is sort of essentially how full or how empty your battery is on average during usage. So if you fill your battery all the way up to 100% and then discharge it all the way to 0%, that is typically leads to faster degradation and faster aging, versus if you discharge to say 80% and fill it to you discharge 20% and fill it to 80%. So this plot is showing battery cycle in a variety of different conditions, and showing how the battery lifetime can vary very broadly from 4,000 cycles all the way down to 142 based on how it's cycled and based on the conditions in which it's operating in. Next slide, please. Right. So moving into actual systems, as we alluded to in the previous discussion, battery packs typically consist of cells in series and parallel. So on the left, this is a Tesla Model S battery pack. And so you can see each of those little dots is basically one cell. Cells connected to modules, connected to packs to form the overall EV lithium-ion battery system. And kind of showing left to right, this is a very simplified picture, but basically, you have these batteries that are hooked up in series and parallel strings that kind of form your overall EV lithium-ion battery. And so in this case, as I mentioned, typically at the beginning of an EV's life, you kind of know they've already gone through this pre-screening process. They're already assembled to be in its optimal configuration, where the health of the batteries is typically, uniform and, very good around or at 100% of its stated capacity. Next slide, please. But the problem is that because due to all these different aging complexities, all these different processes, again, the different conditions of battery, you can think of, maybe the exterior of the pack is maybe hotter than the inside of the pack, things like that. Not every battery ages exactly identically. So you can see in this diagram shown, these bars are sort of indicating the health of the battery at any given at a particular moment in time. They might vary, maybe not wildly, but basically, within some sort of distribution. And again, this is a vast simplification of what's actually happening, but you can think of it sort of the lowest health battery cell affects the health of the pack, and sort of the weakest link sort of affects the overall health of the battery pack as well. So if you have a battery or a string or a module that's is aging a lot faster than the other ones, that affects the overall usage and utility of the overall pack as well. Next slide, please. Right. So this is sort of a problem that I think is more relevant to this group, and that is diagnosing batteries kind of at the end of the first life and the beginning of the second life. So in this presentation, we've sort of been assuming that these batteries follow this curve from 100% down to 80%, and then at 80%, we put in the second life usage, and we're all good to just use it in grid storage until we hit that need. The problem is that we might not know the full current state of health or history of usage just based off of where we get it at the end of first life. You can advance one more time, Menashe, just to get this up. Yeah. So one of the big problems is that we don't exactly know where along the trajectory we might be in a second life. So we might be able, we might take an EV battery out and then be using it for second life, but we might not know if it's at, 90% or 80% or 70% of its original battery capacity. We don't know how it's used. So you can, contrast maybe living in a place like Hawaii where the temperature is very relatively, mild and consistent throughout the year. You're kind of driving bumper to bumper traffic all the time, so you're not really stressing the battery that much compared to somewhere if you're driving, say, in California or New York, you might be commuting long distances, really stressing the battery out, putting it through very hot and very cold temperatures. So in that case, maybe that battery might be used differently and be on a different battery capacity trajectory. So all that's to say, we don't really know the state of the battery when we receive it. And that's one of the kind of the big points of contention and one of the big areas of current research that's going on today to support second life usage. Next slide, please. So there are two ways we think about this. So one is, can we keep track of what's happening in the first life? And so that's what's going on, and for example, in the EU with their battery passport. So this is something that you can use to basically track and keep track of what's happening through the first life of the battery. So you can see here, there's kind of an example on the left-hand side of, keeping track of the battery type, the model, the performance, chain of custody. So basically, how this battery is being moved and used throughout its life. Keeping track of things like its applications. So was it being used in a bus? Was it being used in a passenger vehicle? Was it being used, in different locations and things like that? So, for example, let's say someone was using their car in California, then moved here to Hawaii. This battery passport should be able to keep track of that as well. And when that occurred, to give a more complete picture of the first life that could then be used to diagnose or predict its usage or its evolution in second life. The other one is this diagnosis, at the end of first life, but before we use it in second life. So you can see on the right-hand side, there are many different companies that are working on this, but this is one that has basically what they call a periscope that they can plug into an electric vehicle battery to, run a bunch of different tests to try to diagnose with its current state of life or its current state of health without knowing anything about the first life. So that can then be used to potentially sort or bin these different EV batteries by state of health. And then you can think about even combining these two approaches. The more information, the better. That would just help you understand more about the battery that you're being handed and put it to best use in its second life. Next slide, please. All right. So just trying to sum up here about the value of second life batteries. Why are we doing this? Really, you can think of it, second life batteries are an extension of the lifetime of EV lithium batteries. These new batteries are used in EVs, and then are cycled through EV life, and then can be used again in its second life. The crux of it is that you're avoiding, manufacturing, mining, processing, assembly, all these different things for new battery packs by just reusing the battery packs that are already, out of the world and operating. There's obviously a reduced environmental impact from the manufacturing mining. It's very energy intensive and labor and product intensive processes. You can reduce the cost for these stationary storage systems, because they are not new. There's a certain sort of value, benefit cost analysis that you can do to lower the cost of these batteries as well. And this the kind of the hope and dream of this is that this becomes more part of a more circular economy with recycling. So along that kind of trajectory of first life to second life to recycling, the hope is that at the end of its life, you can try to recover some of those raw materials to recycle to be reused into new battery packs. Yeah, that's sort of the context of this whole issue. Next slide. I believe that's it. Again, thanks for your time, and yeah, happy to answer any questions as well.
Apologies, I do actually have a question. Just there was talk by John Redmond presenting us with UN 38.3 testing, and that whenever a battery is not used as designed and repurposed, needs to might need to be reclassified. Is there any how would you I guess that's where I'm unclear. It's like, what about UN 38.3 testing? Does it when you do this repurposing and the second life, is that part of the equation?
So for OEMs, though producers of cells and batteries, if we are going to bring a battery back for a secondary application, recovering it from a dealer because the battery still has viable life, we would put it back into one of our manufacturing processes to create that battery that would be UN 38.3. We'd be using our components, all of our quality management system to make sure that that battery meets the design type tested. The challenge is going to be if you're having other people without that quality management system, without the knowledge of the battery, bringing those cells and batteries back in to reconfigure and to make a new design type. In order for them to put that in transportation, they would have to meet the UN 38.3 requirements legally. If they're moving it for other purposes, transporting it for other purposes, according to your DOT regulations, 173, 185, but you would have to be transporting it only for testing purposes.
And as I understand, one of the questions you answered was that there are nobody in the state of Hawaii to do this testing.
Yeah, not that I know of. Now, the tests can be done independently. So you could, you don't have to use like a UN or a government approved lab. You could do it, but the cost and equipment needed to do the testing is going to be quite extensive.
Would this be a hurdle for this project?
If you're wanting to do to create new batteries and then put them back on the market, yes, sir.
Well, so yeah, I'm just trying to learn. So according to this presentation, when you go from first life to second life, you're going from an EV to a completely new system, putting these EV batteries in the grid. Would this not necessitate UN 38.3 testing?
Yeah, so that's a really good question and nuance I think that should be explained. So if you pull a battery that's UN 38.3 tested out of a vehicle and you want to do something with it and you're not modifying it, you're going to attach it to your wall or whatever, it's still going to be a UN 38.3 certified battery. Using it in a different application, though, you're not going to be having the same battery management system. It's not going to be managing the cells within the battery the same way. You're using it in a different application. It wouldn't mean that you would have to recertify it, but I think you should take extreme caution to make sure that the way you're using that battery is meeting the same criteria it was designed for. And I see Mr. Cooney's not happy with my answer. I apologize.
No. It's Friday, John. I'm tired.
We have
Yeah, it's
so we have a question in the room. Go ahead.
Yeah, I have a clarifying question. Is this related to the shipping or transport of these batteries? Or is it, so it's a shipping standard versus, so if you were to use it from, let's say, on the island of Oahu, then you wouldn't need to meet any of these requirements, but it would be a question of, let's say, moving it from Kauai to Oahu and shipping it?
No, so if you're putting it on the road, so if you're transporting a battery that you've modified, so that UN 38.3, you've modified that design type to some way, and it's a new design type. It's not a standard, it's the law. It's illegal to transport over a public highway, even across the highway. Even if you have a building on one side of the street and you have a building on across the street, if you're moving that battery across the public roadway, it would be illegal to do so. Now, if you're trying to move a prototype battery for testing purposes from one island to another, now you're going to trigger your prototype provisions, and vessel operators aren't real thrilled about accepting a battery that hasn't been proved as safe for transport and putting it on their vessels. you haven't proven that it won't have a thermal event and that it's a stable battery. So there are some hurdles there as well. If you do change the design type, putting a prototype battery in someone's home or in someone's vehicle, once again, a prototype is one that you haven't proven is safe, and then having people's families be exposed to that is a risk that I would not personally take.
Thank you.
John, if I could help add some context, given the scope of the working group, yes, this is a transportation standard, but I think you brought something really important in. There are a variety of standards that start for one thing and then start to get pulled into other things. And so NFPA, fire safety standards, get used in building codes, but standards also do get pulled into um, insurance underwriting and other types of policies. And we are starting to see the UN 38.3 standards, which were specifically written for transportation, being referenced, normative references in other spaces. And then the other thing I wanted to address is John made a comment about if you took the battery out and you used it in its same format and form factor in a different application, it would still be covered under the 38.3 tests that it was originally subject to. And I agree with and support that comment. What I'd like the participants of the committee to be aware of, though, is that generally speaking, things like the discharge rates, the cooling systems, the battery management systems of batteries, high voltage batteries that are used in EVs are different than what's needed when those same cells and batteries are used in stationary storage applications. So most commonly, and there are some applications that are trying to avoid this, but most commonly, something is done to a battery when it is converted from a transportation battery to a storage battery that would invalidate the 38.3 testing. So whether that's a new battery management system, a new voltage discharge system. And so then we're back into that kind of trick box of we've made a battery that's a prototype. And again, within scope of the regulations, moving that battery for recycling. And I'll say this, it is important that Second Life be a part of the battery ecosystem and life cycle because it is far better environmentally to continue to use. Mindful of when it's done as an artisanal industry, we are creating batteries that are illegal to move, quite potentially.
Thank you, Eric. Representative Martin, thanks for joining us. Go ahead.
Yeah, one of my questions actually Eric just answered in a way. It was whether we need to modify to have that Second Life use or whether we can just take the batteries as is, already pre-approved. But I did have another question for Kevin. In your something that alarmed me a little bit, in one of your visuals, you had the first life as an 8-year period. I believe, I've used my batteries far longer than that. If it's low usage for our short commutes in Hawaii and our mild temperatures, would we expect a much longer first life?
Yes, I believe so. So one of the things I did in one of the direct outputs of my research was showing that the batteries actually do last much longer in kind of both lifetimes than are actually shown here. So yeah, you would expect not only to be lasting longer in first life and typically mild usage in Hawaii, but also even in second life batteries, they might actually last longer in this application as well.
Okay, so yeah, I was hoping that was data that wasn't local. And then my other question is, are the laws regulating transportation, do you feel that were they made at a time when we didn't have a lot of batteries that needed to be repurposed and recycled? Are they, is it worth trying to start a process, which wouldn't necessarily be at the state level, to update those laws? Or do you feel that they're appropriate still?
Yeah, so I'm all for modifying regulation. I spend a significant part of my life along with Mr. Bullish at the United Nations, trying to modify the regulations. Remember, these aren't federal regulations.
Mhm.
These are international regulations because they govern air, ocean, and cross-border shipments. So it is a huge challenge. We work directly a lot with the federal government on the regulations and harmonizing with what the international safety appetite is. So I don't believe moving away from refurbishing and making the legislation less and creating more flexibility within the industry for people to produce batteries or modify batteries that may make them less safe. I think the appetite in the government agencies, especially the US, is to go the other direction, to ensure that if you're modifying a battery, you meet the procedure and criteria for demonstrating and proving through performance testing that the battery that you're exposing the public to is safe. And I don't know of any better tests to do that right now than the UN 38.3.
Yeah.
Thank you.
And I just want to add on really quickly to John's comments. I'm not an expert in sort of the DDR end of life battery, so I'll defer that expertise to those who have it here. But I can attest to the fact that typically second life usage is much milder than first life usage. So, you think about your EV, you're kind of driving on, minutes to hours scale, you're accelerating, decelerating over seconds. In a grid storage scale battery, you can typically operate on the order of hours. So you think about peak shaving, you think about energy arbitrage, that typically happens on the order scale of, 2 to 8 to 12 hours. So much milder usage. There are things we can do to the battery. We talked about having more, changing the BMS to be grid storage BMS. And part of that is, limiting the state of charge you can limit it to a much narrower range than you would for an EV. So that would also help extend the life of the battery. And kind of the combination of some of those, also, stationary storage, you can put in a more temperature controlled environment, to mitigate those temperature induced degradation patterns. So all that, the sum of that is all, you can operate in a much milder condition than you do in an electric vehicle battery that's, driving out on the road every day, versus a second life battery that's, sitting in a storage container somewhere, operating on an hour time scale.
Thanks, Kevin. Danielle, I believe your hand up was up next.
Thanks. So Danielle Spalding, Service Solutions, Battery Recycling. I think I wanted just to bring up one point. I think Monique is actually doing a great job. As I saw, she got into that chat first there, which I think is so great. As part of this work group, right, we know that our goal is to ensure that we're really trying to drive some of these management best practices. So I think the definitions that you'll see starting is a great start for that. But I would also say that one thing that was brought up that I just don't want to have us gloss over, but ensure we focus in on, is the idea of responsibility and responsibility transfer. Because with responsibility also is liability, and it also is consideration of when you have liability, then you've got insurance, you've got other considerations. There's many of these other factors that go into that. And as we evaluate the needs, we kind of go through with this, and I think all of our presenters have been really great so far today. So thank you for John and Kevin. And I know our last is going to be even more amazing. But as we get into this, we have to make sure that we ensure the responsibility transfer, because repair and reman, as Representative Martin has just said, that vehicles can last longer depending on climates, which I think we're all familiar with. But you might want to repair that, or just reman a little bit versus having to completely put into repurposing. So all of those will have different responsibility transfers throughout, and they just need to be very clearly laid out to ensure that is a nice, easy handoff as the whole system is being created here. That is all.
Thank you, Danielle. Dr. Cooney, is your hand new hand or an old hand?
No, it's a new hand. Thanks. It's a question for John. First to comment. Be careful of assuming 8 years is the average life of a battery. It can be much shorter and it can be longer. It all depends upon how the battery is driven, how it's cycled through charging and discharging, whether or not it's sitting out in the sun all the time and it's elevated temperatures. Everything that affects a lead acid battery will affect these batteries as well. So 8 is just an average, but there'll be a lot that's shorter, and there'll be more that are longer. John, question I have for you is, it's well known that, so if you're going to use second lifetime of these batteries, which, as Eric points out, is a good part of the ecosystem, that's going to expose the battery to more cycles of charging and discharge. And it's well known that those cycling of charging and discharging does degrade the internal membrane, which is the protection against short circuiting. In your opinion, professionally, does that extended cycling increase the risk of that battery at the time that it is finally disposed to the waste stream as a DDR status that could potentially short circuit under more easy conditions?
Yeah, that's a really good question, Michael. Yeah, I would probably say that the more cycles exposed to the battery, the more internal degradation that you would see, increasing the level of risk at eventual end of life. I think what would even complicate it more is when an EV is in a vehicle, there's the battery management system, which is kind of the brain of the battery. And it's making sure that the energy is being dissipated between the modules in the cells at a correct level. So it's managing the internal workings of the battery. If you remove that BMS from the EV for the way it was designed, and you're just plugging it into an energy source, you really don't have a way to control the inner workings of that cell or battery. And I think that's a risk as well.
Right, just to clarify, Dr. Kumi, are you talking about the membrane? Do you mean the electrolyte separator to separate within the battery?
Yeah, the internal membrane that basically separates the cathode and the cathode. When it degrades and if it breaks, that's when you get the sudden discharge of electrons or cations towards the other electrodes, and that's when you get the rapid evolution of heat. It's thermal runs.
Yeah, so typically, just to add in a little more color on that, that typically that's when you see the knee in the degradation plot. So that's one of the processes that drives that. And one of the processes that drives the degradation of that membrane is lithium-ion plating and dendrite formation. That process is avoided typically with lower C rates. So in a milder degradation condition, that might not be happening as often. But I do agree that the overall degradation of the membrane could still be possible. But it would be a lot less than if you continue driving it in an EV.
But still, Kevin, by the time you finally send the battery to the waste stream, by the time it finally gets there, it will have been exposed to sufficiently more charge and discharge cycles. And so the membrane will have been degraded more. So that battery is more at risk, I guess, if we could say, to the thermal runaways in shipments.
Yeah, the more cycles placed upon that battery, it's not going to become more healthy and more stable, right? It's going to degrade over cycling. Even if it's lower C rates, over time, it's still going to have some level of degradation.
Right, I agree.
Great. Greg, then Jordan, and then just a reminder, we have one more presentation to go. We packed it in. So go ahead, Greg.
Hello, everyone. So in terms of the degradation of the battery, what we heard on the last presentation, I think my points, and I put it in the chat, is that we know, and I've reviewed and approved many shipments of batteries, thousands of them with 38.3 testing. And it is important, as was stated by the presenters, that is for new batteries that would be considered to be normal to design and then move in transportation. But I also agree with the presenter that said that it's also the only testing that we really have to show that design test process if a battery is returned for evaluation of its health. The challenge that I think we've all seen in the industry with the failures of these batteries is that the OEMs or the people, there isn't really a third party that will test these batteries for their health. And the OEMs are, and at least to my current knowledge, are not willing to certify those batteries unless they're coming back through their plant and repurposed in some way that we may not even ever see that they actually did that or not. But what that leaves is it leaves us with all of the risk if these batteries are used in second life, if they're not being assessed for their health, whether any of the anomalies of degradation or its impedance or any of the factors that could demonstrate degradation of that cell that would warrant it being end of life or DDR managed and not subject to going into second life use. That's a problem because now all the risk goes on whoever's storing it, whoever's transporting it. And because we want to use it in its second life, we now have that risk associated. And if the state of Hawaii is authorizing or at some point based on legislative reform to authorize that right to repair and or second life use, how is that being assured or guaranteed? And when that we have had many incidents across the country of injuries and deaths as a result of improper second life use. And I did like the example of the BMS system. For those on this meeting, it's important for us to know that some manufacturers have done excellent work in their battery management system design to get down to the cellular level to identify anomalies that could warrant notifications for subsequent repair and removal of those modules to deal with bad cells. But others don't meet that same criteria. So they just don't know at the cell level. And it just takes one cell. So I think it's an important thing for us to consider with any type of reuse of what type of guarantees do we have in the state of Hawaii to ensure the acceptance of liability, financial and civil, for decisions that are made and how these would be used in second life. And thank you for allowing me to share that.
Thank you, Greg. Jordan.
Yeah, I was just thinking how when we're talking about 38.3 testing and repurposing for second life, let's give an example. If we're doing a stationary energy storage application, and let's say we're using Nissan Leaf modules, it wouldn't be necessary to retest every time, right? I mean, if you had a set system, maybe a modular type system that fit into a shipping container, and you had tested that system using those cells, and of course, there's going to be different iterations along the years where they, from a 2014 to a 2017, there might be some differences. There usually are. I'm just wondering, though, it wouldn't be necessary every time, right? I guess that's my question, to do the testing, or once we've proven that you have a process and you're using the same cells and the same system down to every component is the same in the design, could that be not need to be tested every time?
So I can take that question, but yeah, so if you're using cells that you got off the market and you believe and you are able to demonstrate those cells are UN38.3, and you took those and you put them into, or even modules, and you put them into a new battery, so you connected multiple of those together electrically, and you went and recertified those and did all that through a management quality process and certified it, then if you were taking that same approach for future batteries, then yeah, they would become a UN38.3 battery, but you would become the company that would be doing that would become the battery manufacturer. So you would certify it, and then you would have to mark and label that battery as your product.
Okay. Yeah. Right. And there was one other thing I was just going to mention too. That's there are different systems, some products that companies have developed that utilize the existing battery management system and a lot of other components inside these batteries. So I know for Tesla battery packs, there is a company, at least two I know of, that make these systems that are able to utilize the existing BMS and some of the other components like the contactors for a second life application, whether that's putting it into some of these EV conversions people are doing, custom EV conversions, or solar energy storage or something else like that. So you can retain more of that safety and more of the redundancy there. But yeah, and it's always going to be some modifications, even if it's just the way the battery's being used. So yeah.
Yeah, I just completely agree, Jordan. So we always want to find secondary uses if we can. So I think the best approach from my perspective would be OEMs contracting with local companies that would be then producing remanufactured batteries under the quality management system using their components so that we can ensure we have a high quality product for the customer. I think the other thing to look at is the quickly growing international fire code and your insurance carrier requirements, where they are starting to look into, well, what type of batteries can you have in people's homes? Consumer Product Safety Commission as well, and putting the consumer at risk for batteries that have been modified. So what kind of testing do you guys need in order to expose the public consumers to batteries? I think it's something to look into, and I think there are a couple of those in my presentation that will be shared. But I would definitely point people to your fire code, which also contains your building code. So it's all under the International Code Council. It's called the IFC 2024. If anyone wants to look into it, they're going to publish a new one, the 2027. But that covers your international fire code. So what sprinkler systems, suppression systems you need in a business. And then you have your building code, which will cover public housing or your private homes as well as businesses. Then you have your insurance carrier requirements. The best one to look at is your FM Global standards, as pretty much everyone in the industry will follow what FM Global is indicating. And then you may have some local fire code as well that you may want to look into. And the 855, so your NFPA 855, aligns with your International Fire Code. International Fire Code is built first, and then that information is what's incorporated into your NFPA 855, which is going to become your new section 903 or whatever it is. So, but I would look at those other standards that are outside of transport. I know a lot about them, but I'm going to stay within my specialty of transportation. Yeah, we may have lost audio for some people.
I was just going to ask the question, John.
Yeah. Yeah, happy to answer.
Go for it.
So I saw Mr. Huang has his hand up as well. I could answer the question there if it's directed towards me, or Danielle, yours as well.
Okay, this is Battalion Chief Pao Chi Huang from Honolulu Fire Department. I just wanted to clarify it's not so much a question. So in the city and county of Honolulu, when you're talking about storage and transport of batteries, EV batteries, lithium batteries, these are under the purview of the building code. In the city and county of Honolulu, the fire code is the building code takes precedence over the fire code. So typically, when you talk about storage and transport, those are covered in the building code. So they use the IBC. IBC uses IFC fire codes regarding these type of topics. So the fire department actually, we're more responsible for we're more emergency response when it comes to these types of topics. So,
do you permit facilities for storage and remanufacturing of lithium batteries?
We don't have anything in the fire code, the Honolulu City fire code regarding those topics. Those are typically Department of Planning permitting building code issue. They're the ones that enforce those.
Thank you.
All right, we had a few technical difficulties in the room, but we're back up. We had a computer die. So Thank you, everyone. I think the conversation kept going. I'm going to go ahead and pass it on to Dan, and we'll pull up my screen for the next presentation. Did anyone not have any more questions on the last two presenters? Great. All right. I'm going to go ahead and share my screen. There we go. All right. Go ahead, Dan, over to you.
Excellent. Well, thank you very much. Really appreciate the invitation from the working group to present here. And I think Kevin and John's presentations, rightfully so, are much more technical than mine will be. So I really appreciated the discussion kind of leading in. My thoughts here, I was going to give kind of the state of the EV market in Hawaii, some of the opportunities that have already been discussed, talk about the actual batteries, and then kind of the auto industry's commitment to sustainable battery management. So just a little bit about the association. We are the Alliance for Automotive Innovation, or Auto Innovators for short. We represent the light duty vehicle industry. This is our most recent family portrait, and as you can see here, we represent nearly every manufacturer that sells vehicles, light duty vehicles in the state of Hawaii, along with tier 1 suppliers, including 5 of the major EV battery manufacturers and a lot of technology companies as well. So really the full value chain of the light duty vehicle industry. We're based in Washington, D.C. I'm out of our Michigan office, and we also have a smaller office in Sacramento. But we also work with Tiffany, who's in the room there as well, on the ground in Hawaii. So again, appreciate the opportunity. If you don't mind, maybe the next slide. So just in terms of the Hawaii market, I thought it'd be helpful to show this is 2024 data. So we'll have new data starting next year on 2025. But in terms of vehicle registrations, there's 1.13 million vehicles were registered in the state of Hawaii in 2024. By powertrain, when you look at that, the internal combustion engine vehicles represented about 96, almost 97%. Battery electric vehicles were about 2.6, plug-in hybrids 0.8, and fuel cell vehicles were very small, didn't quite register on the percentages there. In terms of new vehicle sales, we're averaging about 70,000. 2024 was a little lower than previous years, but to be expected. That was kind of the trend for the full or for the whole country. Again, when you look at powertrain for new vehicle sales, we actually saw electric vehicles were rather high in terms of comparing to other states in the state of Hawaii. Hawaii had about just under 10% if you take into, or sorry, just under 11% if you take into account battery electric and plug-in hybrids. Next slide, please. When you look at this over the past 5 years, you can see that market share of EVs and hybrids has continued to, hybrids particularly, has continued to grow. In 2025, year to date, we have seen, or actually, sorry, not year to date, going back to July, a dip from where we were in 2024 to just under 10% EVs. And when we say EVs, that's pure battery electric and plug-in electric hybrid vehicles, just under 10%. That was about on course with what we saw nationally as well. I will say that you will see when we do have the data, there was a significant spike in September as the federal EV tax credit expired at the end of the month. We saw in terms of national sales, just under 14% new vehicle sales being electrified. That was the highest month in that we've had to date. Following that, in the month of October, we saw a significant dip nationally, looking at the lowest it had been in 3 years. So looking by powertrain, I did just want to highlight that we have continued to see in Hawaii decreasing internal combustion engine vehicles, or ICE vehicles. And we've seen an increasing, particularly over the last year and a half or so, of hybrid electric vehicles. So even as we're seeing that dip in what we would consider ZEVs or electric vehicles, hybrid electric vehicles are continuing to increase. This is, again, similar to what we've seen nationally. We've seen some dips and hybrids continue to grow. So the auto industry remains committed to cleaner transportation, whether that be hybrids or electric vehicles. We're still going to continue to see certainly HEVs rise, and we'll see where, once the tax credit has expired and looking probably closer to the first quarter of next year, where that kind of water level falls out with electric vehicles. Next slide, please. In terms of model availability and segment sales, so today there are 155 different EV models available for sale in the U.S. The slide on the graph on the left shows the types of those electric vehicles. We've seen a significant increase in light trucks. That includes utility vehicles, so your sport utility, your crossovers, those types of vehicles, minivans and pickups. It's about just under 80% of the EV market. This was actually a decrease from the high of the first quarter of 2024, but still significant portion of the market. And again, utility vehicles, like I said, crossover sport utility vehicles, up from 19% in 2020 to just over 70% today. So that is the segment. What we're seeing is those early years of electric vehicles being, very rather small and compact and not maybe necessarily meeting the needs of general consumers, to getting to where we are today, that there are, again, 155 different models on the road today. 71% of those are being those crossovers and those sports utility vehicles that we have seen a growth in, including in internal combustion engine vehicles. Next slide, please. Not sure if it's my screen or if we're...
Sorry, I'm trying to host the
Oh, you're
meeting. Share screen is very hard. One sec.
No worries at all.
Yeah. Sure. Okay.
If it's helpful in the room, I believe I have the ability to share if that's easier.
If you can, go for it. We've
Yeah,
had
let me
some
do
security
that.
issues.
I'm using two monitors and not trying to run a meeting, so it might be a little easier for me.
Awesome. Thank you.
Yep. Are you able to see my screen?
Yes.
Awesome. Okay. Shifting to EV battery recycling. So I'm not going to go into this. I know there's been discussions on this in the past, but I did want to include, we are supportive of all of these different opportunities, but as John had alluded to, making sure that they're done in a safe manner going forward. Again, not something I'm going to dwell on. I will just highlight here some of the opportunities. As we, the one issue that seems to have bipartisan support in Washington, D.C. these days are national energy security and reducing our dependency on China. Battery recycling, repurposing is an opportunity to do that. So that is one thing of very few that actually crosses party lines that we've been able to see some advancement in Washington, D.C. I did just want to spend a couple minutes on kind of when we talk about these EV batteries, and John did a great job of highlighting this, of the size and weight of these. When we look at this, and this is a Volkswagen kind of cutaway, just showing the actual system inside the vehicle. The weight, size, and voltage of these batteries is going to require professional removal. So similar to internal combustion engines and transmissions. Certainly there will be some that do-it-yourselfers that try to tinker with this, but again, this is something that will likely require professional removal. So it will not be something like, a lead acid battery in a traditional internal combustion engine vehicle. And I thought this slide was somewhat helpful, just kind of putting into context what this actually looks like. So on the left, you see a typical lead acid batteries, oftentimes less than 50 pounds. When you look at a hybrid vehicle battery, this is not a traditional plug-in, but more of a just traditional hybrid. You've got various chemistries, so there's a wide range there, but typically less than 130 pounds. When you get to the EV battery, and again, obviously this depends on the vehicle, the range of the vehicle, and the battery chemistry, that can get up to 3,000 pounds. When you look at that compared to a traditional internal combustion engine vehicle, a V8 engine is less than 750 pounds. So when we're looking at this, we're actually talking about an EV battery being much larger in terms of weight than a V8 engine, including the transmission, so a full V8 powertrain. So again, just kind of putting into context, because I know it's easy to say, yeah, it's heavy, but one of the things that we've said is, these batteries aren't going to just end up, on the side of the road or ditch. It's going to, the size and weight by themselves will prevent that. And I don't want to spend too much time on this, but just showing Kevin did a great job of kind of highlighting the opportunity of secondary use. What you see here, this is actually from 2018, I believe. This is a BMW battery storage farm in Germany. So these are all used EV batteries. There's 500 of them here, and they're being used to store wind energy at a BMW manufacturing facility in Germany. So again, as Kevin mentioned, Kevin, I think, was using 80% state of health after the vehicle retires. Typical average vehicle life in the state of Hawaii is 11.2 years. The batteries can last that long, even if they do degrade lower than 80%, but you're still 70% range. These are still very viable opportunities for batteries. And what I think we're going to see play out is the economics between, is it better to get a battery to secondary use, or is it better to get a battery into recycling and get the critical minerals back into the supply chain to then build new batteries? And I think that still will depend on the circumstances, and economics will play a large role in that. So next, I just wanted to talk about a little bit automaker partnerships with battery recyclers. So I pulled literally every OEM member that we have has had some sort of partnership with battery recyclers. So this is just highlighting that our manufacturers, our members, see an incredible opportunity with EV battery recycling. As I mentioned, this is something that can help increase the domestic supply chain of critical minerals that are currently mostly coming from China today, and keep that domestic and get those battery materials right back into new batteries. So again, not going to touch on all of these here, but there's a lot of partnerships, and this is just a smattering of them. Some manufacturers have partnerships with multiple recyclers because they want to ensure that they've got an opportunity to get, again, those battery supplies back into their electric vehicle batteries. I'll note that I know Redwood has been part of these meetings before. They just opened a facility in South Carolina, and they opened it there because there's a lot of EV manufacturing in the state of South Carolina. So again, it's looking at how do we quickly get those materials back into the supply chain. So lastly, I'll just highlight this. And again, I know this is going quick, but I think, John and Kevin did a really good job of getting into the details here. But as I mentioned, we are committed to sustainable battery management. We want to ensure that we're not hindering any opportunities for repurposing and recycling. We want to make sure that as this battery recycling industry is just starting to grow, that we're not putting into place policies that could hinder that growth. I mentioned already, looking to national energy security, this stabilizes some of that supply chain. And as I, kind of showed that we've seen a decline in EV sales, it's going to find its watermark. But with that declining, we have about a $12,000 difference between a traditional internal combustion engine vehicle and an electric vehicle. We need to be cognizant of the fact that we're not putting into place policies that would inadvertently increase those costs. And the last thing I'll mention, we are in the process of launching a pilot program in the states of California, Oregon, and Washington. This will be similar to a program that's up and running in the country, or in Canada today, where essentially the vehicle manufacturers have said if there's an unwanted battery in Canada, we will take responsibility for the proper handling of that battery. So there is a website that is managed by Call to Recycle that actually has contact information for every manufacturer that sells a vehicle or an electric vehicle in Canada, where the owner of that unwanted battery can reach out, and it is a responsibility then for them, the manufacturers, to ensure proper handling of that. So our plan is to launch that pilot program in Q1. We chose those 3 states because that's where we've seen the highest concentration of electric vehicles. So we're going to start there, at least to get our feet wet and understand the nuances there. And would be happy to keep this group, whether it's part of the working group here or the legislature in Hawaii, up to speed or updated on how that program is playing out. So with that, again, I do really appreciate the opportunity to present here today. My email address is here. Please, if you have any questions or would like any information on the data I've shared, would be happy to do so. And with that, happy to answer any questions.
Great. Thank you so much, Dan. Any questions? I do have one, but I'll save it unless there's others. Going to just slide 10, and this might be a question for you, Dan, or other folks in the working group, but I think a lot of times people think of like repurposing for stationary storage at the individual home level. So like putting these sort of individual power packs for stationary storage at the home level. Do you think there's like increased safety when doing it more at, the commercial scale for some of these, larger IPP type developments, utility scale type developments?
So I can answer to what slide 10 has here, and then John probably and Kevin would have more details. But I mean, if you think of it, these batteries that you're seeing here all came out of a BMW vehicle. So BMW is using these batteries that they have designed, tested, have in-depth knowledge of the battery management systems, et cetera, and able to use those in their own facility. So there is a in-depth knowledge of the design parameters of the batteries. So in terms of, my personal opinion, do I think this is safer than, a do-it-yourselfer using a battery at their home? Yes, I do. But I'm sure there's, testing and other things that can go into that. But John, I see you're on camera, so happy to get your input as well.
Yeah, I think it's another great question and something that everyone needs to think through. So this is controlled, right? The risk is there. And probably if you look at the energy density, if something goes wrong here, it's going to be really serious. And I would point people back to the Moss Point lithium battery energy storage facility in California. They're still trying to clean it up, but it's controlled. So you're using the OEM's BMS, you're using an OEM controlled system, OEM controlled evaluation of the batteries, and they're managing it through a BMS. The concern I would have is, although if you take one of these batteries and put it in someone's home, how do you ensure it's safe? And maybe most of them are. I don't really track energy storage system fires in private homes, but I would probably, well, I won't even guess, but I would say that's a greater risk for me, just because I don't know how well it's being controlled in that environment.
That's very helpful. Thank you. Other questions? I do see quite a few notes in the chat, just noting that all of that does get saved and recorded and sent out in the meeting minutes. Anyone else? Go ahead, Dr. Cooney.
I'm going to circle this one back to John, I think, and our speaker, but first with a comment. So it's, as Eric pointed out, there's an ecosystem here that should be supported to expand the use of lithium-ion batteries and all of that, and have a lot of businesses grow within it. That's great. But I do caution everyone to remember that at the end of the day, all of these lithium-ion batteries will enter into the waste stream. And I encourage everyone to consider, what does that waste stream look like in Hawaii? Because it's not a really clean little set of boxes that the batteries go into straight to a ship. They end up in 70 abandoned cars in a homeless encampment on an isolated road. They end up behind auto dealerships. They end up in warehouses stacked 20 high. They end up in containers at salvage yards. They end up in backyards, and they end up thrown away in valleys in dry wooded areas. That is kind of where we're headed for where the waste stream is. And that's in the absence of having a clear stewardship program running a process where 95% of the batteries can be collected and rendered or deactivated so they're not flammable. So circling to what that's, and in my third report, which is the working group, we found out through declarations that there are no batteries being declared as lithium-ion batteries leaving the islands. And that's because It's either they're going under universal waste or they're not being declared or they're just being abandoned. So we really have no way of tracking what's out there. So the I guess the question for John, or I'm echoing what he said, is he talked about when you take these batteries and you put them in homes, right? And that's increasing. That's another push by the legislature to give rebates for people to put these batteries in their homes. I have a solar system and I have an inverter, and it took me 4 months to replace it when it went bad. The question that I have is, if I put a battery on the side of my house, and my house is close to other houses next to me, they're all based in wood. If my battery had gone bad, or it started to heat up one day, and I think maybe, I don't know if everyone saw that video 2-3 months ago that was circling around on YouTube about a house in Kaimuki that had one of their batteries start to explode on the side of a house. If it's going to take me 4 months to get my inverter, how do I get rid of my battery if it starts to heat up one day? Because there is no mechanism right now. I don't know who to call. I don't know who to dispose it to. I don't even know how much it's going to cost. So I consider that like a looming problem, that if we don't have a stewardship program that's statewide, we don't have a centralized facility to take these batteries in and render them deactivated, I'm not sure where we're going to end up. Because I thought what John pointed up about how do you actually observe these batteries at homes, I'm not even aware of when they install them, whether there's any system measuring their temperature. And 2 months ago, a Tesla battery started to explode in a house. There were 10 firemen there. They were trying to put it out. And I think it was just sheer luck that somebody saw it. So, John, do you have a comment on that? Is that going to become a bigger issue?
Yeah, maybe like 2 comments. So I remember one of the earliest meetings that we had, you were talking about we have to have a solution to make sure the batteries are recovered. Insurance carriers have to be a part of that, because they're really what's going to drive what a vessel operator can accept on their ship.
Agree.
So I think that is a great and valid point that we shouldn't lose sight of. I think the second one is, with all the batteries being recovered, the OEMs, if it's a warranty battery, the vast majority of OEMs are going to recover that from the dealer. Now, we do have arrangements, and remember, even if it's a universal waste battery, a battery that's a universal waste can only be transported as universal waste if it's not designated as DDR. If it's a DDR battery, it takes precedent over that universal waste. So for EPA, you can still declare it as a universal waste and manage it as a universal waste, but it has to be transported as a DDR battery, which means it has to be in PG1 packaging. It has to have some thermal protection. It has to be surrounded by non-combustible, non-flammable material. It has to be impact resistant. And so I think there may be a gap there that we should probably, like, at some point, the industry should look at, to make sure that that's being done. PHMSA has put out, in alliance with EPA, warnings and notifications that if you have batteries that are DDR, they have to be transported as one, with EPA coming in saying, yes, you can't just treat it as a universal waste. It has to be transported under the DDR provisions. So you have government agency alignment there. Now, if
Okay,
people
so
aren't
really quick, John, you talked about like there is the warranty, so to speak. But
Yeah.
let's say, because I have solar cells on my roof. Let's say a dealer came by my house, because I get the flyers all the time, and they wanted to sell me a battery that came from a car. So it's the repurposing, as Kevin was talking about. If I accepted that because it's cheaper, so to speak, let's say it's half the cost, right? And I go for that deal. Has that fallen out of the manufacturer responsibility because it's now second purpose, second use, second owner?
Yeah, you're using it for a manner in which it's not intended by the manufacturer, right?
So it's not covered anymore. It's going to be totally my
it would not
cost.
be covered under the liability of the OEM if you're putting it in a house and it's a vehicle battery, right? So just to go back, that if there's a warranty failure, most likely, I don't know how you get out of it, but most likely that battery is going to be damaged or defective. It's going to meet that criteria. You're pulling it out of the vehicle for some reason. So there has to be some evaluation, probably DTC codes, but you'll know that you should understand that that battery is probably damaged defective, has to be transported as such. If you declare it as damaged defective, no vessel operator is going to want to take it. So the question would be is what are people doing with their damaged defective batteries right now, and how are they being managed? Are they putting them in landfill? Are they putting them in the back of a storage facility? You know, whatever the examples you have. Now, if someone comes to me and says, I want to put a battery on my house or in my garage, you know, and I always think when my mind is crazy, it always goes to the worst case scenario. But I can imagine my 3 daughters sleeping in the room above where that energy storage system is. I want there to be some early detection. I want there to be a gas detectant. So if the battery starts to fail, it'll start producing, you know, HF. So if I can have some HF detectant and heat radiant detecting early warning to allow me to get out and get my family out of the house if something started to fail, that's what I would prefer. Now, I've seen things talking about suppression systems. You're not going to be able to generate enough water if it's a larger scale battery to extinguish it, right? So you may be able to protect some of the damage, but I can show you tons of videos of vehicle fires parked next to houses. I shouldn't say tons. I can show you a few where a vehicle is parked next to a house and it's had some sort of abuse that people weren't aware that it would be danger, and then allowing it to have a thermal event, or to your point, parked next to something else, like an electrical panel that ended up having a failure, and you had EVs next to it that, you know, contributed to the overall fire, and sometimes even a nice vehicle. But the early detection is what I would probably recommend. And I don't think that's codified right now, but it probably ought to
Okay,
be.
so let's say we got it codified and there's early detection. And let's say I'm at my house and it's on the side of my house and the early detection kicks in and I can make the phone call to somebody. The problem then comes in once that early detection system's kicked in, that battery's DDR. And right now I can't ship it. So I have no place to send it.
Yeah, so you could ship a DDR battery, but you can't get it off the island, right? And that's the problem. And so I think the best solution for me that I've seen is if you have a DDR battery, you can't, if you try and ship it, you're either going to have packaging that's going to cost $60, $70, $80,000 a piece to try and contain that thermal event, or you try and process it on the battery in the safest on the island on the safest way manageable. And that's where I like the black mass idea. It's clean. All you're doing is shredding a battery. You're not really like treating waste. You're shredding a battery into a black mass so that it can be managed and transported more safely off the island. And then you could really, you haven't created such a significant hurdle where people are trying to bypass the regulations by not declaring them and putting them on boat, or hiding them in storage facilities, forests, dumping them in the ocean or whatever. You create a viable path for them to be processed. And
Yeah,
that's
I
kind of
agree.
where I lean.
Our report came to that conclusion. We need a public accessible wet shredder option on this island for that exact reason. That's
Yeah, I think
exactly what we recommended to the West Energy Office.
yeah, I know it's not an attractive option for everyone, but when you start looking at all the data, I think it's the one that's most pragmatic and makes the most sense. And you know, we probably have to have strong controls around it. We don't want to, you know, impact our environment. And you know, I'm all about safety of people, environment, and processes. So we definitely want to protect the environment, but I don't know a better way to protect the environment than creating an avenue for them to be processed safely and environmentally friendly. And that's that black mass, in my opinion.
No,
Thank
I
you.
agree.
Very helpful. We are 5 minutes past time, and I do want to be respectful of folks' time, but I also hate cutting off the conversation. Lene, you did have one
I have
question.
one
Go ahead.
question for Dan. Can you give me a little bit more detail on your pilot? How will the batteries be collected? Should it be, if no outlet is available? And where would it go? And how will it be managed? And how will it be paid for?
Can folks hear Dan talking, or is that audio on our end?
I'm sorry, I was
Oh.
double muted.
Oh, you.
Sorry. Nope, completely on this side. The program has been up and running in Canada, and we've actually seen very few unwanted batteries get into the program. The industry seems to be working itself through it. But essentially what you would do is if you had an unwanted battery, there would be contact information for either the vehicle manufacturer to manage it themselves, or they could contract with a third party. It would then be the responsibility for paying for that through the vehicle manufacturer. It would also be up to them if that went to a recycling facility or to be repurposed. So it's really the OEM or the vehicle manufacturer taking responsibility and saying that if it's an unwanted battery, that they would take responsibility. Part of the reason that we want to run this pilot is, we haven't seen, at least on the mainland, a lot of these unwanted batteries getting out of the system as it's working. We've seen battery recyclers say that, if there's a battery that's unwanted, call us, we will pay you to take that battery. So the system seems to be working, at least like I said, on the mainland. But we don't have any actual data for that. So part of the pilot is we have these 3 states that have 3 of the highest EV penetration rates. Let's see if this is an actual problem on the mainland. And if it is, what do we need to do to address that? And if it's not, we at least have a data point there. So not sure if that sufficiently answers your question though.
So if there is very little unwanted batteries, how are other states already collecting the unwanted batteries, and say whether it's DDRs or end of life in various stages, such that there is no unwanted batteries out there?
Yeah, can I answer that one, Monique?
Yeah.
So Monique,
Please,
I think it's a really good question. So in the States, we recover the damaged affected batteries from the dealers, and we pull them directly back to a recycler or to our R&D facilities. And we can do that by truck. There's packaging that you can use to protect it. And then what I would say is for an OEM battery, that you have the 3 things. You have the DTC code, so you can get information how it's working internally within the battery and what the risks is to the battery malfunctioning itself. You have your visible observations, so your physical observations of the battery. And then you can use some equipment like your heat guns and stuff like that to try and glean additional information on if it's stable for transport. And then you put it in the required packaging. I think the challenge for Hawaii is that you have to move it by vessel. And that means you're going to be having a container with high density of potentially damaged affected batteries placed on a sea, and the vessel ship can't pull over like a truck can. And so there's a lot of risk and a lot of cost if something goes incorrectly. And that's the main difference. So far in the States, we take it straight from a dealer into a recycler. Redwood is a great ally for the industry. When you're looking at Hawaii, there's no recycling, there's no partner to take the batteries to, so you have to move them back to the States, and that vessel portion is where there's a significant amount of risk to not only people, but property and the environment.
So not to put you on a spot, but okay, so say we find a way to process the batteries for shipment via vessel to a recycler. Being that the dealers are now not taking and accepting this directly, would the dealers be willing to pay for that cost?
So right now, it's an OEM by OEM perspective, and Dan Bowerson could probably speak on what the industry is doing. But the industry's position right now, for the most part, and I don't want to talk about either my OEM or any specific OEM, but the industry as a whole, for the most part, if it's a warranty battery, we'll recover that warranty battery and we'll take it back and process it. If someone brings a battery to a dealer, we'll normally be processing that battery. I think to Mr. Cooney's perspective, there's nothing mandating us to do that. And I believe AAI has a proposal or kind of like a framework of legislation that they would support that would allow or where the automotive industry would agree to recovering all the batteries and as well as orphan batteries as well. So a battery that wasn't an OEM, it's outside of warranty, and it's, finds its way to a dealership or somewhere, that there would be a process established for recovering that and processing it appropriately.
John, I want to circle back to that into Lene's question. So you talk about it being covered under warranty, but what about those cars that go into second and third hand markets, like second ownership, third ownership, and maybe eventually just end up at a student at UH and gets abandoned when they leave, or military?
Yeah,
they're not going to be covered, correct?
Yeah. So I think that's that orphan battery proposal that the automotive industry has. That if it's a battery, just not a warranty battery claim that we're getting in, but it's outside of warranty and, it's a third generation hand down vehicle. It's there at end of life. Well, what do you do with it? You're not going to just dump it in a salvage yard. They're not going to have the capabilities to manage that battery. You don't want to just left it in the public and creating a public nuisance. I believe that's where that proposal is, to recover those batteries.
Okay. And so
on the cost of the OEM.
One more concept on that. So you talk about, right, so they're trying to do the right thing. That seems to me to be maybe viable for the mainland, because you're really only dealing with transportation by railroad and trucking. Are they going to be willing to pay the extra cost of ocean shipping and the inclusive of the higher insurance rates? Do you think that's really long-term something that the state of Hawaii should gamble on?
Yeah, so that's a really good question. So, working with integrity is what I pride myself on, and my company prides himself on. So we are looking at solutions and working with vessel operators and packaging fabricators to develop systems in place to be able to move those safely, and to recover the batteries that we come in contact with, however we come in contact with. I think that there's nothing forcing everyone to do that, and I think that's a proposal from AAI that they have, which I think it's a good starting point of what the legislation should be. Now, the vessel operators are still going to have serious challenges with putting them on their vessel, and so until there's some sort of black mass generation on the island, it's going to be very difficult and super costly. And when you have a regulatory requirement that is so burdensome that, to recover a $20,000 battery is going to cost you $80,000, people are going to find alternatives to that. And when they do, that's what puts the environment and people at risk, where I think the best opportunity is that black mass generation.
So do you agree with our working report conclusion that the best option for Hawaii to avoid all these risks is to have an on-island wet shredding facility open to the public, so that we can produce at least a crude shred that is non-battery components that is safe for shipping, and that leaves us all the options on the table at much lower rates? And that's probably the best way to go then.
So I think I do, and I think for the following reasons. One is, if you create that process, you will actually capture how many DDR batteries you're generating on the island, which is kind of hidden right now. So you'll get clarity and being able to understand really the scope of the work that you have. And then two, I think that you'll really understand at that point as well is, was the risk to Hawaii as a whole? Where are these batteries? Where were they before this? Where were they landing? So I think you create an environmentally friendly solution. I think you reduce the risk during transportation, and you have a better understanding of the scope of the problem that you have.
Thanks, John. Pao-Chi, go ahead, and then this will be the last question, and we can continue this at the next working group meeting.
So this is Lieutenant Chief Pao-Chi with Honolulu Fire Department. So I've been in a lot of meetings regarding this, and it does seem like the sort of the gap in Hawaii is that there is no black box. I think he called it the recycling mechanism, and there is no way to ship things legally out of this state. We're left with basically a huge hole. And that has been identified in multiple meetings. So I think that's what needs to be addressed is what is the solution to get these things off the island? One idea, like just popped off top of my head, is that to require all companies that are selling these, everybody's saying, oh, how great EV and how great lithium ion, we're going to go green. But then everybody who's making a profit selling these things, like the auto dealership, once it leaves their lot, that EV battery is just out in the wild, and it could end up in a field. It could end up in a recycling yard. It can end up somehow when we deal with a fire, that thing's gonna burn, and then they're gonna end up as universal waste. So you have the public going, well, where do we do with this? Would it not make sense for a company who is selling these lithium-ion batteries to also be responsible as a place for the public to say, hey, this is a GM vehicle. I'm going to call the GM dealer, and the GM dealer is obligated to assist them with recycling these things. If I buy something from Battery Bill, that's a lithium battery, like a power pack, and the consumer is like, hey, this is beyond its life. We purchased this from the vendor. I'm going to go back to the vendors. How do I dispose of it? And they're required to offer the solution for this. You cannot require the public to know that these things are regulated under UN 38.3. The people who should know this would be the people selling it. Right now, the fire department is getting questions. How do you recycle this? How do you do that? It is out of our lane, but they don't know who to go to. So I really feel the solution is for the state and the city and county to figure out some legislation to say, hey, if you're going to sell these things, are you accounting for the recycling of these items? I know it's wonderful to talk about, hey, let's recycle, reuse, but the truth is, even after reuse, we still got to get it off the island, right? So I think that's the whole this is just my comment. That's what's missing. I think it's great that we want to reuse, but they brought up Michael, I think, brings up a great point. I was like, wow, he hit the nail right on the head. The whole is we have nowhere to recycle it. We have no way to ship this off the island legally. So that's my comments.
Yeah, Chief Wong, I would say that there's a couple different proposals out there. I think the PRBA, Mark Belush was on the call. They have what they call their a recommended bill legislation that has that EPR, the extended producer responsibilities, that if OEM has something on the market, that they're required to recover that item. And it's a pretty good piece of legislation. They represent just about all the different OEMs. Dan Bowerson has one as well. But I would recommend looking at those two and recommended regulations that could be voted on, approved, and then implemented. I think New Jersey is kind of the model bill for that right now. But they do have different model bills that I think would be a good starting point for this group to consider. I think the second thing is that, some of the OEMs out there are doing the right thing. So they will take the batteries back. I think where it becomes difficult is that battery that then goes to another company that modifies it for their own uses and then resells it to someone else. Who should be responsible for that one, I think, is a little bit of a gray area. It's hard to go back to the original OEM that says, hey, we put this on the product for a vehicle. Someone else has taken it off, modified our product, and now resold it. It seems like that person should be responsible for those type of items. But I think those model legislations or those model bills would really help kind of frame the conversation.
Thank you, John. Really appreciate it. And I do want to just note, so those the end of life what to do with the battery when it reaches end of life. Those are topics for our next two meetings. So the next meeting is going to be December 18th, 9 to 11. We'll get the agenda out on that. And I know we are already 20 minutes over time. So really appreciate everyone who stuck around and everyone's contributions. It's we have a large scope to cover, and the further we dig into it, I think the larger the scope becomes, and the details associated with transfer of responsibility, modification. A lot of those are big questions. So appreciate everyone being here. And then again, the next two meetings, I think we're really going to get into some of these end of life options, which will give us a larger understanding. These first meetings are really focused on reuse, repurposing, recycling, and then end of life options is coming up next. So meeting minutes will be posted on our webpage. Next meeting, December 18th, 9 to 11. And we very much,
Public comments?
any public comments? I didn't see anyone from the public, so thank you again, and everyone have a good Aloha Friday, and we will see you next month, and a good Thanksgiving.
Thank you.
Thank you.
Hey, thank you all.
Thanks.